Hey guys, welcome. Yeah, so problem 6, and therefore the last problem on the 2018 AB FRQ, and it's a slope fields question. And in part A, what we're asked to do is graph the solution curve going through the point 0, comma 2, and also through the point 1, comma 0. Now, remember, the slope field is like a mini tangent line on the solution curves. So it's the tangent lines of the original function f or y, right? Whose derivative is given here, right? And so basically, we need to draw solution curves hugging these mini tangent lines. And so the solution curve going through 0, comma 2 will have to just be a horizontal line like that, because look at all the tangent lines. They're horizontal. So there that is. And the solution curve going through the point 1, comma 0, look at the way the mini tangent lines are shaped. So we'll have to follow that shape. And so it's going to look like this on this portion. Perhaps I draw it in a different color, but I guess red is fine. And then it's going to mirror itself. And it's not like quite a V there. It's supposed to be, I'll start here, I guess. I'm using like a curve drawing tool. And like, yeah, if you start at a point, like it like makes it look like, you get it. It's roughly like that. Yeah? Okay. Only that minimum is supposed to be symmetric about the y. Okay, so can I do better? Let's try it one more time, guys. So I'll start to turn around there. Okay. No, I missed the point. Okay. But you get it. I'm not going to do that again. Okay, so there it is. Just make sure that it goes through that point. But roughly that is good enough. Okay, so that's it for part A. And so this is easy points. And let's move on to part B. And part B says, let y equal f of x. So like, you know, one of the two we've drawn, so that's going to be like, but this time it's like the particular solution going through f of 1 being 0. So going through the point 1, comma 0. So it's a particular solution going through 1, comma 0. So it's that like kind of like curvy thing I drew, right? Okay. What about it? So they say write an equation of the tangent line to that graph that I drew at x equals 1. Okay, we've done equations of tangent lines many a time. First, know that in point slope form, the equation of the tangent line is going to be y minus y1 is equal to m times x minus x1, right? Okay, so we need a point, x1 comma y1. How lucky. We have it right here. So this is x1 comma y1. Got it? And then we need the slope m. Well, the slope m at the point 1, comma 0 is just dy dx evaluated at 1, comma 0. And notice that to evaluate dy dx, we need both x and y coordinates. So important that we wrote both coordinates here, right? Of the point x1, comma y1, the only point we know about. Okay, so then dy dx evaluated at the point 1, comma 0 is going to equal, it's going to equal the following, right? It's going to equal a third times x is 1, so a third times 1, and then y is 0, so 0 minus 2 squared. So if you simplify all that, you just get 4 over 3. So m is 4 over 3, and then our point is 1, comma 0, so the equation of the tangent line is going to be y minus 0 is equal to m, which is 4/3, times x minus x1 is 1, so minus 1. So that's going to say y is equal to 4/3 x and then minus 4/3, right? Okay, cool. There that is. And then we're asked to use this tangent line to approximate f of 0.7. Now, note that 0.7, first of all, this is like a good way to approximate f, right? So let's write that this is an approximation of f of x. But yeah, f of 0.7, then note that 0.7 can be written as 7/10. So we could write f of 7/10, and that's going to equal 4/3 times 7/10, and then minus 4/3, right? And okay, so we can cancel here into a 2 and a 5 there. So what do we get? If I move across over here, I'm gonna get 2 times 7, so that's 14. 14 over 3 times 5 is 15. 14 over 15 minus 4/3, which I can write as minus 20 over 15. That way I can subtract easily. And then I get negative 6 over 15, which reduces to, canceling by 3 top and bottom, reduces to negative 2 over 5, right? Okay, cool. So f of 0.7 is roughly equal to negative 2/5. So that's that, and that's part B. And then finally, part C, and part C says this. Find the particular solution, y equals f of x, to the given differential equation with initial condition f of 1 equals 0. So it's saying, knowing that 1, 0 is a point on the function f, so given this initial condition, find f. All right, so this is a typical separation of variables question. So first, from this differential equation, and by the way, I have lots of videos on differential equations, so look for them and feel free to watch as many of them as you want, and I'll make a lot more. But yeah, separation of variables is pretty straightforward. We separate the variables, literally, as the name says. So we get dy, and then underneath it we can write the stuff involving y, so that's y minus 2 squared equals, and then on the right side we'll get the x's, so that's 1/3 x times dx, right? Okay, cool. And now for integration purposes, because we're going to integrate both sides of this equation, so for integration purposes, let's rewrite the left hand side as y minus 2 to the negative 2 times dy, and then equals 1/3 x dx. And now I'm ready to integrate. And I guess let's get fancy and do it in black. I've been doing blue and red, but let's do it in black now. Okay, so there we are. So the left side should be pretty easy to see. We'll have antiderivative y minus 2 to the negative 1 divided by negative 1, and then plus a constant, but I'm going to get a constant on the right side too. So I'm going to combine those two constants and just write it on the right side. So I'll have this equals, and then the antiderivative on the right side will have to be 1/3 times x squared over 2, and so that's just x squared over 6. And then, like I said, I will have combined the constant from the left and from the right on the right hand side, so x squared over 6, and then I'll write my constant here now, plus c. I took a constant from here, and from there I combined them into just this plus c on the right side. Okay, cool. Now we can write the left side as clearly as negative 1 divided by y minus 2, and the right side is x squared divided by 6 plus c, right? Okay, cool. Now, since we have this initial condition, and we can at this point, if we so chose, find c, I'm going to do that right now. So I'm going to plug in 0 for y right here, and then 1 for x right here, so I can solve for c. So if I do that, I'm going to get on the left side negative 1 divided by y 0, so 0 minus 2 is just negative 2, equals, and then, equals, and then on the right side, I'll have x is 1, so I'll have a 1/6 plus c. And the left side is just 1/2, so I have 1/2, and if I subtract the 1/6 from the right side onto the left side, then I will be able to solve for c, so minus a 1/6 is equal to c. And the 1/2 is what? 3/6, so 3/6 minus 2/6 is c, minus a 1/6. I'm like looking to the answer, is equal to c, and then that's going to equal 2/6 or 1/3. So we see that this constant c is going to have to be 1/3. All right, cool. And because I see a denominator of 6 underneath the x squared, I'm going to write 1/3 as 2/6, and you'll see what conveniences come out of doing so. So we get 2 over 6 right here. Got it. We're almost there, guys. We're almost done. Okay, so I get rid of this, and now what? Now, I guess I could move this up. Right, so now we can do this, right? We can do, on the left side, we have negative 1 over y minus 2, and then on the right side, we can write x squared plus 2 all over 6. Now, you can cross multiply and get to what I'm about to write, but you could also accomplish the whole cross multiplying and simplifying by simply flipping the fraction on the left and flipping the fraction on the right. Because if you have a over b is equal to c over d, then it's true that b over a will equal d over c. So I'm just going to use this. So that'll say y minus 2 divided by a negative 1 on the left. And on the right side, I'm going to write 6 divided by x squared plus 2. But I want to take care of this minus 1 right now. So I'm going to multiply both sides of this, both numerator and denominator of this fraction by negative 1. So when I do, I'm going to get 2 minus y in the numerator. So I'd prefer to do that. So 2 minus y, and remember, we have flipped the right side. So we have 6 divided by x squared plus 2. Right? And all that remains to be done is to add y to both sides of this equation and subtract 6 divided by x squared plus 2 from both sides of this equation, and then we're done, right? So our solution, which is our particular solution, which is y equals f of x, is going to have to equal 2 minus 6 divided by x squared plus 2. And that is it. And this concludes the 2018 ABF FRQ solutions. Yeah? All right, cool. I hope you enjoyed my solutions and also that you learned a lot. All right, take care. Bye.